This question belongs to algorithm subject and was asked in GATE CSE 2015. So the question states, given below are some algorithms and some algorithm design patterns. So these are algorithms, these are the design patterns. Dijkstra'S shortest path, Floyd-Warshall algorithm to compute all pairs shortest path, binary search on a sorted array, and backtracking search on a graph. And patterns are divide and conquer, dynamic programming, greedy design, DFS and BFS. Match the above algorithms on the left to the design paradigms, they follow codes. So we have to match the algorithms to the design pattern. So what is a Dijkstra algorithm? So in Dijkstra algorithm, we will have a graph given, it can be directed, it is a directed or an undirected graph. And we need to find a single source shortest path. So distance from a particular source to a particular destination, we need to find this. And how it is done? So if we are at a particular source, we try to go to the shortest neighbor, the neighbor which is the closest or takes the lesser cost. So it's basically a greedy design. So greedy always try to choose the optimal path at a particular point of time. So Dijkstra is mapped to greedy. So first is mapped to 3. Then we have Floyd-Warshall. So Floyd-Warshall is basically all pair shortest path. What is the shortest path? From A to all other, from B to all other, C to all other, D to all other vertices, and E to all other vertices. And it uses dynamic programming to do the same. So Floyd-Warshall, which is second, is mapped to DP, which is 2. Now what is binary search? So we are in binary search on a sorted array. So we have been given a sorted array 20, 30, 50. So what we does is that we come to the middle item, and if we are searching, let us suppose 20, let us suppose 30. Then we see whether 30 is less than this or more than this. 30 is more than this. So we discard the left part and go to the right part. So which means here we are dividing the entire thing to 2 parts, and then we are going to any one part to solve the problem. So binary search is basically based on divide and conquer. Now we have backtracking search on a graph. So suppose we have a graph like this. So what is DFS and BFS? Suppose we have vertices like A, B, C, D, like this we have. So what is BFS? BFS means that we will go first breadthwise, which means first we will go to A, then to all the neighbors of A, which are B, C, D, then to all neighbors of B, which are E, then to all neighbors of C, then to all neighbors of D, then to all neighbors of F. And what is DFS? So DFS will go depth first. It will go first to any depth. So let us suppose it goes to A, then it goes to B, then it goes to E, then it goes to F. And from here it does the backtrack, and then it goes to C, then to D. So backtracking is basically done by DFS. So fourth is mapped to our option 4. So answer is option C. 1 mapped to 3, 2 mapped to 2, 3 mapped to 1, and 4 mapped to 4. So option C is correct.